This is, quite possibly, the greatest deception in human history. Our entire lives, we've been fed a beautiful fairy tale. A story of noble scientists peering into the cosmic abyss, searching for intelligent brethren. A narrative of a grand, humanistic quest, one meant to unite us all. But what if I told you that all of it was just a smokescreen? What if, behind the veneer of this magnificent project, a completely different, darker, and more terrifying objective has been hidden for decades? What if backstage, a real war has unfolded, a war not for contact, but for control, a war for our very future? Did you believe the great silence of the universe was merely a scientific enigma? What if in reality it is the primary weapon in this very war? What if the entire search for life was betrayed from within by those who initiated it? Today, we will expose the clandestine protocols and reveal how the grand dream of contact transformed into a cynical business plan for galactic conquest. You will discover why the cosmos is truly silent, and what terrifying truth this silence has unveiled, not about aliens, but about ourselves. We will recount how one single photograph became the most potent propaganda tool, and how the most famous signal in SETI history might not have been what it seemed at all. This is not merely a story about aliens. This is a saga of power, betrayal, and the greatest swindle the entire world has ever bought into. Prepare yourselves, because after this video, you will never be able to look at the stars the same way again. Make sure to watch until the very end. The truth will prove far more shocking than any science fiction. There exists a single fact that, if you truly ponder it, has the power to upend our entire perception of reality. A fact not about distant galaxies or black holes, but about our own place in the universe. By even the most conservative estimates, in our Milky Way galaxy alone, there are approximately 40 billion Earth-like planets. These are rocky worlds, orbiting their stars at the perfect distance where water can exist in liquid form. 40 billion potential cradles for life. And if we consider that across the entire observable universe there are hundreds of billions of galaxies, then the number of possible habitable worlds becomes virtually unimaginable. Statistically, by all laws of probability, the cosmos should literally be teeming with life. And here then, the paradox emerges, deafening in its simplicity. Despite this inconceivable number of possibilities, despite decades of searching, we observe absolutely nothing. We point colossal radio telescopes skyward, listening intently into the cosmic silence, and yet we detect not a single artificial signal. We analyze the light from distant stars as it passes through their planets' atmospheres, and we find no undeniable traces of a biosphere. The universe is silent. This vast, universal silence is the most perplexing and unsettling fact modern science has ever encountered. It's like arriving at a massive stadium where millions of spectators should be present, according to their tickets, only to discover you are completely alone. Let me clarify up front. This won't be merely a collection of fanciful hypotheses about little green men or a narrative of unconvincing UFO photographs. Instead, this will be an epic scientific investigation, a detective story of cosmic proportions. We will endeavor to comprehend why this shocking contradiction exists between what should be and what we observe. We will examine the evidence, analyze the theories, and weigh the proof, all to draw closer to unraveling the ultimate mystery. Are we alone in the universe, or are we simply not yet capable of seeing or hearing others? And what astounds me most here isn't the mere idea of aliens, but the irrefutable logic of numbers. The laws of physics and chemistry that gave rise to life on Earth are universal. Carbon, hydrogen, oxygen, these elements are scattered throughout the cosmos. Stellar energy has shone for billions of years, providing more than ample time for evolution to unfold. The universe has provided all the necessary ingredients, all the conditions, and virtually infinite time. From a scientific perspective, the emergence of life appears not as a miracle, but as an almost inevitable chemical process. And it is precisely this inevitability that renders the cosmic silence so deafening and almost unbearable. Before we begin analyzing the evidence, let's pause for a moment and try to immerse ourselves in the very atmosphere of this grand quest. Imagine not the roar of a launch pad, but the almost monastic stillness of a colossal radio telescope's control room. The air here is cool and dry, smelling of ozone from the active electronics and a faint aroma of overheated plastic. The only sound is the low, continuous hum of servers churning through terabytes of data and a barely audible hiss from the speakers. This is the universe's background noise, the cosmic microwave background radiation, the remnant echo of the Big Bang. Within this hiss, this cosmic birth echo of the world, scientists search for a meaningful pattern, an anomaly, a singular note amidst the chaos. Now, let us mentally transport ourselves to an astrobiology lab. The scent here is different, sterile, clinical, with a faint metallic hint from meteorite fragments stored in vacuum chambers. It is the scent of anticipating a miracle, one that must be confirmed not by feeling, but by the readings of a mass spectrometer. To comprehend the logic of modern researchers, one must grasp several key codes or principles that are woven into their thinking and dictate their entire search strategy. The first and most fundamental of these is the concept of the habitable zone, or, as astronomers affectionately call it, the Goldilocks zone. This isn't a specific location, but rather the ideal range of distances from a star where it's not too hot and not too cold. It's a narrow band where a planet receives just enough energy for water to exist in liquid form on its surface, neither boiling into vapor nor freezing into ice. It's within this zone, like the perfect porridge from the fairy tale, that they primarily search for planets. This is the first, crudest filter, sifting out billions of inherently unsuitable worlds. The second principle, without which modern search is inconceivable, is the concept of a biomarker. Scientists understand that the chances of seeing an alien spacecraft or conversing with its pilot are negligible. Therefore, they are not searching for life itself, but for its chemical exhaust, its atmospheric signature on a planet. On Earth, for example, oxygen serves as such a biomarker. In a chemically active environment, it shouldn't exist in such quantities in free form. It's continuously produced by plants. If we discover an atmosphere on a distant planet rich in both oxygen and, say, methane, gases that ordinarily destroy each other, that would constitute extremely powerful indirect evidence. This would indicate that some constant process, most likely biological, is continuously replenishing their supplies. We're not searching for the creature itself, but for its breath, captured and frozen in the spectrum of light. The third and perhaps most crucial code is philosophical in nature. It's the Copernican principle, or the principle of mediocrity. It posits that neither Earth, nor the solar system, nor our galaxy occupies any special, privileged position in the universe. We are not at the center of creation. And if that's the case, then the conditions that gave rise to life here cannot be unique. They must recur again and again elsewhere. This principle isn't a scientific fact, but rather a working hypothesis, an intellectual gamble. Yet, it's precisely this gamble that instills confidence in scientists and compels them to continue their search, despite the cosmos's deafening silence. They operate on the assumption that we are not a miracle, but a statistical norm. And here we arrive at the most precise and confident analogy that explains the essence of the entire process. The modern search for extraterrestrial life is the most extensive archaeological expedition in human history. Scientists are not communicators waiting for a phone call, but cosmic archaeologists. They don't expect to find a living city, but hope to uncover its ruins. The radio signal that the SETI project seeks is not an invitation to dialogue, but perhaps merely an echo of a long-perished civilization. Chemical anomalies in atmospheres are not proof of alien forests, but rather chemical fossils, traces of an ancient biosphere preserved over millions of years. We patiently sift through the sands of time and space in search of shards from a broken vase. Any deviations from the natural background that might turn out to be traces of alien biology or technology. This approach is stripped of the romanticism of first contact, but full of scientific excitement and rigorous discipline. It transforms the search from a lottery into systematic work. We're not just looking at the stars, we're looking for artifacts. And now, armed with this understanding, we can move to the first and most obvious excavation site, our own solar system. For most of the 20th century, discussions about extraterrestrial life remained the domain of science fiction writers, not serious scientists. In academic circles, the topic was considered at best speculative, at worst outright fringe. The universe was the subject of physics and astronomy, but certainly not biology. Life was perceived as a unique, almost magical phenomenon occurring exclusively on our planet. The very thought of searching for it anywhere else seemed almost improper, akin to attempting to scientifically prove the existence of elves. But in the history of science, as in any drama, there inevitably comes a moment when the status quo collapses under the weight of one audacious idea or event. Such a catalyst, a turning point that initiated an irreversible shift in consciousness, was the Viking mission in 1976. This was more than just sending another probe to the Red Planet. For the first time in history, humanity dared not just to look at another world, but to literally touch it in search of life. The Viking 1 and Viking 2 landers carried not only cameras and weather sensors, but also a miniature, fully automated biological laboratory. It was the boldest and most expensive biological experiment in history, conducted from hundreds of millions of miles away. Its goal was to collect a sample of Martian soil and test whether it contained microbes that breathed, ate, and excreted waste products. It was at this moment that the main engine of history stepped onto the stage. The man who became the voice and soul of this new scientific discipline, Carl Sagan. He was not merely a brilliant astronomer. He was a visionary, a popularizer, and a poet of the cosmos, possessing the rare gift of discussing the most complex subjects simply, infectiously, and with the deepest intellectual respect for his audience. Sagan and his like-minded colleagues, such as Frank Drake, offered the world a revolutionary concept. Life is not an earthly miracle, but a cosmic imperative. They argued that if the laws of physics and chemistry are universal, then their product, life, must be as well. This idea, proclaimed from a scientific platform, was incredibly daring for its time. It transformed the search for aliens from an amusement into a fundamental scientific endeavor. At the core of their conviction lay a simple yet powerful observation. The building blocks of life are ubiquitous. Analysis of meteorites that fell to Earth revealed that they contained complex organic molecules, including amino acids, the very bricks from which proteins are built. This meant that prebiotic chemistry, which precedes the emergence of life, is not a rare process, but a standard operation that the universe performs in asteroid belts, in gas and dust clouds, and on cold comets. Life, from this perspective, did not assemble itself from nothing in Earth's warm pond. Its ingredients were delivered here from space, and if they were delivered to us, then why couldn't they have been delivered to billions of other planets? To say the least, the scientific community's reaction to this new paradigm was deeply polarized. It created an intellectual chasm that stretched wide. On one side, ardent enthusiasts were electrified by the sheer audacity and grand scale of the idea. On the other, the vast majority of conservative scientists regarded it with profound skepticism. To their minds, this was not science, but mere philosophy, a collection of untestable, almost fanciful assumptions. Projects like SETI, which sought to detect radio signals from afar, wrestled for funding and were often dismissed by many as eccentric, even whimsical endeavors. The very phrase, "searching for little green men," was invoked with a cutting irony, a clear dismissal that this was anything but a serious scientific pursuit. Then, however, the results from the Viking experiments landed, and they proved to be even more bewildering than anyone had dared to imagine. They offered no simple yes or no answer. Instead, the Martian soil displayed incredibly unusual and heightened chemical activity. Some scientists interpreted this as a potential hallmark of metabolism from unknown microbes, while others countered that it was merely the effect of powerful oxidizers in the soil, entirely unrelated to biological processes. This debate, a tenacious one, remains unresolved to this very day. Yet, it was precisely this tantalizing ambiguity, this profound mystery, that truly poured fuel on the fire. It hinted that other worlds were not merely inert spheres of sterile rock. Their chemistry, it suggested, could be intricate, dynamic, and utterly alien to anything we knew on Earth. And so, catalyzed by the audacious spirit of a few pioneering scientists and the perplexing data returned from Mars, a brand new discipline was born: astrobiology. It did not spring into existence overnight, but rather, over several transformative decades, it evolved from a niche, almost fringe, pursuit into one of the most captivating and swiftly advancing frontiers of research. The formidable barrier separating the realm of pure science fiction from the rigorous domain of hard science had been decisively breached. And now, an even grander, more ambitious challenge loomed before scientists. If life could truly flourish beyond Earth, how precisely does it operate? What fundamental mechanisms underpin its very existence? To truly grasp where to seek out life, we must first unravel its fundamental architecture, examining it at its most basic engineering level. And here, let us be clear, there is no whisper of mysticism, only the stark reality of pure, elegant, and relentlessly efficient chemistry at play. At the core of everything we define as life lies one single, extraordinary chemical element, a kind of universal soldier, a brilliant architect of the molecular realm. Its name is carbon. The astonishing tapestry of life on Earth, from the simplest virus to the majestic blue whale, from sprawling fungal networks to the intricacies of the human mind, all of it is, in essence, one vast, incredibly intricate drama, meticulously choreographed by carbon atoms. Hence, our guiding metaphor is elegantly straightforward. Carbon chemistry is far more than a mere collection of reactions. It is the most sophisticated molecular construction kit in the entire cosmos, from which literally anything can be built. Now, let us peer under the hood of this cosmic construction kit and truly grasp what makes it so extraordinarily good. The secret lies entirely within the carbon atom's unique capabilities. It boasts 4 valence electrons. Imagine them as 4 eager hands poised to latch onto other atoms. Not 2 like oxygen or 3 like nitrogen, but precisely 4. This quadruple bonding capacity bestows upon it an unparalleled, almost fantastical versatility. Carbon can forge long, robust, and remarkably stable chains, a feat unmatched by any other element. It can readily bind with itself, creating the fundamental skeletal frameworks for colossal molecules. It can effortlessly sculpt rings, intricate branched structures, and even form potent double and triple bonds. Carbon, in essence, is the quintessential building block, profoundly versatile and supremely dependable. It possesses the innate ability to engineer molecular architectures of staggering complexity yet astonishing stability, architectures that underpin proteins, lipids, and most crucially, the very carriers of genetic information such as DNA and RNA. Yet, even the finest bricks are useless without mortar and a building site. In our unfolding story, water takes on this crucial role. Liquid water acts as a magnificent chemical ballroom, a universal solvent where carbon molecules can freely drift, encounter one another, interact, and engage in reactions. Water creates the perfect environment for complex chemical processes to proceed not chaotically, but with elegant order. It stabilizes temperature, transports substances, and participates in thousands of biochemical reactions. Without this liquid medium, even the most intricate carbon molecules would remain inert dust. This is precisely why the astrobiologist's mantra rings true: follow the water. Wherever liquid water is present, the carbon construction kit might just get to work. However, any construction kit, any building project, demands energy. And here, life discovered two ingenious engineering solutions. The first and most obvious is the energy of stars. Photosynthesis is the process by which plants and certain bacteria learn to tap directly into this thermonuclear reactor, utilizing light to split water and forge energy-rich organic molecules. But there is a second, more exotic source, the chemical energy hidden deep within a planet's interior. In the utter darkness of the ocean depths, near searing hot hydrothermal vents, the so-called black smokers, entire ecosystems thrive not on light, but on the oxidation of sulfur compounds and other chemicals erupting from beneath the Earth's crust. This process, known as chemosynthesis, proves that life can exist even far from the nurturing embrace of a parent star. Now let us visualize this entire process, step by step. Step 1. On a young rocky planet within the habitable zone, comets and asteroids deliver water and the simplest organic compounds, the very parts of our carbon construction kit. Step 2. Oceans form on the planet, becoming a colossal chemical soup where these molecules dissolve. Step 3. A source of energy emerges, either sunlight penetrating the upper layers of water or heat from volcanic activity at the bottom. Step 4. Fueled by this energy, molecules begin to actively combine, growing in complexity, forming ever longer and more diverse chains. And finally, Step 5. The most mysterious and pivotal moment. One of these intricate molecules serendipitously acquires the astonishing ability to create copies of itself. At this precise juncture, non-living chemistry transforms into living biology. A replicator emerges. Evolution begins. A question often arises: why carbon specifically? After all, in the same group of the periodic table, directly beneath it, sits silicon, which also possesses 4 hands. Theoretically, it could have formed the basis for an alternative kind of life. However, an engineering analysis reveals its fatal flaws. Silicon chains are far less stable than their carbon counterparts, and crucially, the product of its breathing is silicon dioxide. While carbon dioxide, which we exhale, is a gas readily soluble in the atmosphere and water and poised for a new cycle, silicon dioxide is quite simply sand, a solid substance. Imagine a civilization that exhaled sand. Such a biochemistry would very swiftly bury itself under layers of solid waste. Nature did not choose carbon by chance. It was, quite simply, the superior engineering solution. So, now we possess a clear understanding of the mechanics of this marvel. Life is not magic. It is a self-assembling chemical machine built on carbon, dissolved in water, and powered by energy. This straightforward formula is our primary tool, our guiding map, pointing directly to where we should search. We must seek out worlds boasting 3 essential components: liquid water, complex organic matter, and an energy source. Armed with this map, we can finally embark on our initial voyage and explore the most promising locations right in our cosmic backyard within our very own solar system. We speak of gigantic telescopes, intricate chemical reactions, and distant worlds. But amidst this grand tableau, it is all too easy to forget that the quest for extraterrestrial life is, above all else, a deeply human story. To truly grasp the immense scale of this undertaking, let us begin not with numbers, but with a single, tangible fact. Picture a radio astronomer dedicated to the SETI project. Their workday, and more often their night, for decades on end, consists of one singular act: listening to the static hiss of the cosmos. This represents 40 years of near-absolute guaranteed silence, traded for the slender hope that one day, for one fleeting second, that monotonous hiss might be punctuated by something truly meaningful. It is a marathon of faith, endurance, and extraordinary patience, run not by machines, but by people. And among these people are truly unsung heroes, without whom this multi-billion-dollar endeavor would be doomed to utter failure. One such hero is not an astronomer, but a programmer, meticulously crafting data filters. Their task is paradoxical. They must teach a machine to ignore humanity itself. Every single day on Earth, thousands of satellites, cell networks, television towers, aircraft radars, even ordinary microwave ovens, all conspire to create an unimaginable cacophony of radio frequency noise. This engineer's job is to forge an impenetrable digital barrier, one that will meticulously filter out every single earthly signal, ensuring that only the pure, untainted whispers of the universe remain in the data stream. They are building a wall to cordon themselves off from humanity itself, so they might hear someone else. But there is an even more astonishing and largely unknown profession standing guard over the integrity of this monumental search. This is the Planetary Protection Officer. This individual is neither an astronaut nor a physicist. Their paramount responsibility is to ensure that we do not inadvertently contaminate other worlds with earthbound microbes, and perhaps even more critically, that we do not accidentally bring back some alien life form from Mars or Europa. This is the most critical border control in the entire universe, and its primary mission is to avert a planetary-scale catastrophe. This is the individual who guarantees that if we do discover something, it will indeed be alien and not merely one of our own bacteria, having hitchhiked 500 million miles on the hull of a Mars rover. The work of this officer and their dedicated team often feels like a scene lifted directly from a science fiction film. Mars rovers and landers are not assembled in typical workshops, but rather in meticulously sterilized, clean rooms, where the air is thousands of times purer than in a surgical operating theater. Engineers work clad in suits that resemble spacesuits, completely enveloping their bodies. Every single tool, every screw, every microchip undergoes a multi-stage decontamination process before assembly. All of this is done with one paramount objective: to ensure that not a single earthly spore, not one stray skin cell, not one virus remains on the spacecraft being sent to another world. And it is here that we encounter a truly astonishing everyday detail that vividly illustrates the utter seriousness of this approach. Before a Mars rover is finally sealed into its capsule for dispatch into the cosmos, it is entirely baked. A multi-billion-dollar piece of machinery is placed inside a colossal oven and held at temperatures exceeding 100 degrees Celsius for tens of hours. This procedure is called thermal sterilization, and its purpose is to eradicate anything that might have accidentally survived all previous cleaning efforts. In essence, we are sending to Mars the most sterile object ever crafted by human hands. It represents the pinnacle of our commitment to experimental purity. This almost fanatical meticulousness is far more than a mere scientific eccentricity. It is rooted in a profound ethical principle that could be articulated as the cosmic commandment to do no harm. Scientists are keenly aware that if Mars or the icy depths of Europa harbor their own unique and fragile biosphere, the introduction of even a single earthbound bacterium could lead to its complete annihilation. Our life, forged through billions of years of relentless competition, might prove to be an incredibly aggressive, invasive species for another ecosystem. And we certainly do not wish to go down in history as the civilization that, having just ventured into space, immediately caused an interplanetary ecological disaster. So, when we gaze upon the breathtaking panoramas beamed back from Mars, or analyze the complex data from distant telescopes, it is crucial to remember the thousands of unsung individuals behind the scenes. Those who have spent decades listening to the silence, who write intricate code to filter out the noise of our own civilization, and who, with an almost religious reverence, meticulously sterilize every single gram of metal sent toward other worlds. The search for life in the universe is not solely a technological challenge. It is, perhaps more importantly, a profound test of our own humanity, patience, and responsibility. For decades, the search for extraterrestrial life followed a clearly defined and seemingly impeccably logical path. Scientists, like diligent students, adhered to a simple formula: seek out planets resembling Earth, orbiting sun-like stars at just the right distance within the Goldilocks zone. It was a clear, straightforward, and focused strategy. This allowed them to filter out trillions of unsuitable candidates and zero in on the most promising ones. The system operated like a well-oiled machine, and the entire scientific community eagerly awaited the moment this mechanism would finally yield results. Then, right in the midst of these methodical quests, something entirely unexpected happened. Right here in our own solar system, practically under our noses, discoveries were made that shattered this elegant theory into ruins. The perfect storm had arrived. It all began with data gathered by spacecraft exploring the moons of Jupiter and Saturn. Initially, these were just tantalizing hints, but with each new mission, the picture grew increasingly astonishing. It turned out that beneath the icy crust of Jupiter's moon, Europa, a colossal ocean of liquid water lay hidden, its volume surpassing all of Earth's oceans combined. Then the Cassini probe flew directly through geysers erupting from cracks at the south pole of Saturn's moon Enceladus, and analysis revealed these plumes were composed of salty water and complex organic molecules. These worlds were located far beyond the traditional Goldilocks zone. They should have been dead, frozen solid to their cores. Yet they proved to be alive, warm from within, and possessing all three key ingredients for life: water, organic compounds, and energy. Energy they drew not from the sun, but from the tidal friction generated by their gas giant planets. This discovery was more than just a refinement. It was a knockout blow to the entire existing paradigm. It turned out that the habitable zone isn't necessarily a narrow belt around a star. It can exist in the form of hidden subsurface oceans virtually anywhere. Life doesn't require starlight. The planet's internal heat is sufficient. We had been searching for life on brightly lit beaches beside a warm sea, while it, perhaps, had been serenely thriving all this time in the deep, perpetual darkness at the bottom of an ocean hidden beneath miles of ice. The search area suddenly expanded by thousands of times, rendering the previous strategy woefully naive. It was at this very moment that the dialectic of strength and weakness in our approach became apparent. The strong suit of our strategy, its focus on Earth-like conditions, revealed itself as its primary vulnerability. We had been searching so diligently for our own reflection in the cosmic mirror that we risked overlooking anything that didn't resemble us. Our logic was akin to someone searching for lost keys, not where they dropped them, but under a lamppost, simply because the light is better there. The discoveries on Europa and Enceladus demonstrated that the keys could lie anywhere, and often in the deepest, most impenetrable darkness, places we hadn't even thought to look. But this was only the first jolt of the storm. The second came from the research into exoplanets. For a long time, astronomers largely ignored the most common type of star in our galaxy: red dwarfs. They are dim, cool, and their planets, to receive enough warmth, must orbit so closely that they become tidally locked, forever showing one side to their star. Furthermore, red dwarfs are unstable and prone to powerful radiation flares. They seemed like the worst places for life to emerge. But then, the Kepler Space Telescope and subsequent surveys revealed that Earth-like planets around such stars are not the exception, but the rule. The most famous example is the TRAPPIST-1 system, where 7 rocky planets orbit a single tiny red dwarf, 3 of which reside in the habitable zone. This new reality forced scientists to completely overhaul their models. It became clear that the most numerous and perhaps oldest cradles of life in the galaxy might be found around these very unpromising stars. Theorists scrambled to re-evaluate the conditions. Could a thick atmosphere redistribute heat on a tidally locked planet? Could subsurface life be shielded from radiation flares? To all these questions, the answer increasingly became, yes, it's possible. The search shifted from rare, sun-like stars to countless vastly different red dwarfs. And this leads us to a new, even more unsettling realization. We once thought the main challenge was simply to find at least one suitable planet among billions of barren rocks. But now it seems the universe is literally teeming with potentially habitable worlds. They just aren't what we expected. They might be dark and cold on the outside, yet warm within. They might orbit dim, unstable stars. Life could turn out to be a far more common, but also a far stranger phenomenon than we ever dared to imagine. And looking at all of this, the biggest question hangs in the air, creating maximum tension. What if the great silence of the universe isn't a sign of life's absence, but merely a reflection of our own blindness and deafness? What if the cosmos isn't silent at all, but screaming on thousands of different frequencies, speaking in millions of chemical languages, and we, tuned to one single, solitary frequency, our own, are simply incapable of hearing it? When we face the great silence, the simplest explanations seem the most logical. Either there's no one out there, or everyone's hiding, or they died out long ago. But intellectual honesty demands we acknowledge that more complex, less dramatic answers might exist, residing within the very realm of science itself. One such alternative theory is known as the rare Earth hypothesis. It posits that for complex multicellular life, like our own, to emerge, merely having a planet in the habitable zone isn't enough. A long, almost improbable list of coincidences is required. You need a large moon to stabilize the planet's rotational axis and ensure a predictable climate. You need plate tectonics to regulate the carbon cycle and prevent the planet from overheating or freezing solid. You need a gigantic neighbor like Jupiter to act as a cosmic bouncer, shielding the inner planets from comet bombardment. According to this hypothesis, the simplest microbial life might be widespread, but hitting the jackpot of all these conditions for the emergence of animals and intelligence, that's an event of extraordinary rarity. The universe might be full of swamps, but only on 1 out of 1 trillion planets in such a swamp will thinking reeds grow. Another, equally elegant hypothesis is called the Gaian bottleneck. It turns the problem on its head. Perhaps the main filter weeding out civilizations isn't their inability to develop, but rather their failure to survive at the very earliest stage. Any young biosphere actively begins to change its planet. And if it doesn't quickly learn to regulate climate and chemical balance on a planetary scale, it will inevitably lead its cradle to catastrophe, either to an uncontrolled greenhouse effect, like on Venus, or to complete freezing, like on Mars. In other words, life sterilizes itself before it can even take hold. According to this model, Earth isn't just a lucky planet. It's a planet whose biosphere won a deadly game, learning to maintain homeostasis and transforming into a single superorganism, Gaia. And billions of other worlds might have turned into graveyards for life that perished from its own success. We see no one because almost no one passes this first, most brutal survival test. But all these fascinating theories and searches run up against one very earthly and prosaic factor: money. The Great Search is an incredibly expensive undertaking. Let's, for a moment, translate these astronomical sums into human terms. The cost of the James Webb Space Telescope, our primary tool for analyzing exoplanet atmospheres, amounted to roughly $10 billion. For that money, more than 20 state-of-the-art hospitals, fully equipped with the latest technology, could have been built. Or hundreds of thousands of students could have been provided with free university education. The cost of the Viking program in today's money would exceed $6 billion. And these colossal resources are being spent not on solving pressing issues, but on an attempt to answer a philosophical question. The very fact that our civilization is willing to incur such expenses speaks volumes. There is a hidden, almost symbolic meaning in this decision. These projects are our modern cathedrals. In the Middle Ages, society poured unimaginable resources into building colossal temples that took decades, even centuries, to construct. These cathedrals had no direct practical application. Their purpose was to connect humanity with something larger, with eternity, with the divine. Today, science and space fulfill this role. Constructing a gigantic telescope or sending a rover to Mars is our way of asking the same eternal questions our ancestors posed while gazing at the cathedral vaults. Who are we? Where do we come from? And are we alone? In this light, even an act like the launch of the Voyager probes with their famous golden records takes on a different resonance. These records contain sounds and images of Earth, a greeting for a hypothetical civilization that might find them millions of years from now. From a practical standpoint, this is utterly meaningless. The chance of anyone finding this tiny needle in a cosmic haystack is infinitesimally small. But this was a message not so much to them as it was to ourselves. It was a symbolic manifesto of our civilization, an attempt to affirm our existence, to tell the universe, we were here, we thought, we loved, and we dreamed. It is an act of pure art, a desperate and beautiful gesture cast into eternity. Thus, the economics of the search for life are not just budget line items. They are an indicator of our civilizational priorities. We spend this money because we understand that the answer to the question of other life will change us forever, no matter what that answer is. A positive answer will prove we are not alone. A negative one, obtained after centuries of searching, will make us feel even more isolated, but also force us to recognize the incredible value and fragility of our own world. This quest is the most expensive and most crucial investment in our self-awareness. And now, having seen all the pieces of this gigantic mosaic, the picture begins to achieve a frightening clarity. We have observed the paradox of numbers colliding with dead silence. We have disassembled the chemical machine of life down to its nuts and bolts and understood its basic principles. We have peered behind the curtain of the great search and appraised the scale of human effort. We have experienced the shock of discoveries in our own solar system that shattered old dogmas, and we have weighed elegant yet somber hypotheses about great filters. All these threads, seemingly disparate, lead to one point, to one synthesis, which may not offer us a comforting answer, but will allow us, at last, to understand the nature of the great silence. It seems we have been asking the wrong question all this time. We asked, where is everyone? But this question implicitly assumes that everyone is someone like us, technologically advanced, curious, eager for contact, building radio transmitters. We were searching for a reflection of ourselves. But what if that is a fundamental error? What if life's primary goal isn't to build a civilization, but simply to survive? Life isn't an engineer striving for technological peaks. Life is an opportunist that occupies any available niche and adapts to it. And the most numerous and stable niches in the universe might be entirely unlike our own. Imagine life existing in Europa's subsurface ocean. For it, there are no stars, no sky, no day, and no night. Its world is one of eternal darkness, crushing water pressure and chemical gradients around hydrothermal vents. It could be complex, diverse, even forming entire ecosystems, yet it would never have the impetus to develop vision, emerge onto land, or gaze into the cosmos. It has no sky to explore. Why would it need radio? The same holds true for billions of planets orbiting red dwarf stars, where life might be hiding deep beneath the surface, sheltering from radiation. The universe could literally teem with life, but this life would be deep-dwelling, microbial, invisible, and silent. It exists, but it isn't civilization as we understand it. And this brings us to the core of the mystery's solution. The Great Silence isn't a single solitary filter, but rather a combination of at least three powerful factors acting in sequence. Factor number 1, life likely emerges frequently, but in the overwhelming majority of cases, it remains simple, microbial, and hidden in subsurface niches, lacking both the opportunity and the impetus for further complexity. The universe, in all likelihood, isn't a desert, but a colossal microbial ocean. Factor number 2 is the rare Earth hypothesis. On those rare planets where conditions do allow life to break free from the subsurface and embark on complex evolution, an improbable chain of coincidences comes into play. For a microbe to evolve into a thinking observer, a unique confluence of astrophysical and geological conditions is required. A stable star, the precise axial tilt, a protective magnetic field, plate tectonics, a giant planetary guardian nearby. The probability of assembling this cosmic royal flush is vanishingly small. Therefore, complex life capable of developing intelligence is no longer the rule, but an exceptional rarity. And finally, the third and most merciless factor, time. Even if a technological civilization has emerged elsewhere, what are the odds that its period of existence would overlap with ours? The universe's history spans nearly 14 billion years. Humanity's history, capable of listening to the cosmos, spans less than 100 years. That's not even a flicker. It's a vanishingly small fraction of a second on cosmic clocks. Other civilizations could have appeared and vanished billions of years before us. Others may emerge billions of years after we're gone. The cosmos isn't a bustling town square, but a vast, dark theater where actors step onto the stage one by one in different epochs, delivering their monologues to an empty house. We hear no one because we are alone on stage right now. And this, then, is the grand synthesis. The solution to the Great Silence phenomenon is that it isn't a paradox at all. It's the normal, natural state of the universe. The universe isn't silent. It's just largely filled with something other than what we're looking for. It's teeming with microbial life, not engineers. It only very rarely creates the conditions for intelligence to emerge. And it scatters these rare occurrences across such colossal temporal and spatial distances that they virtually never intersect. We find no signs of intelligence because intelligence is the rarest and most fragile phenomenon in the cosmos. This transcends politics and warfare. This is a design of titanic, almost divine proportions. Realizing this changes everything. It strips us of hope for meeting fellow intelligent beings, but in return, it grants something far more precious. It transforms our planet from just one among many into the rarest cosmic diamond. And it transforms us from ordinary inhabitants of the universe into its guardians, into carriers of something incredibly precious and perhaps unique, the capacity to ask questions and seek their answers. The Great Silence isn't a verdict. It's a challenge. It's an echo that, reflecting off the void, compels us to hear our own voice. The grand search, even without providing a definitive answer, has already irreversibly changed the world in which we live. Its legacy isn't abstract philosophy, but tangible technologies, ideas, and even words that we use every single day. This process is like a domino effect, where a single scientific endeavor aimed at the cosmos tips a tile that triggers a whole chain of events right here on Earth. The most striking example of this is the technology by which you might be watching this video right now. I'm talking about Wi-Fi. In the late 1970s, Australian radio astronomer John O'Sullivan was tackling a complex problem. He was trying to detect faint, distorted radio signals from exploding microscopic black holes. For this, he had to develop an ingenious mathematical framework capable of extracting a clean signal from the chaos of cosmic interference. He never found signals from black holes, But the algorithms he created proved to be the perfect solution for another problem: wireless data transmission in the noisy environment of urban apartments. Thus, an attempt to hear the whisper of a dying black hole gifted humanity wireless internet. And this is not an isolated incident. Image processing algorithms for the Hubble Space Telescope formed the basis for improved mammography, and technologies for analyzing Martian soil are now used in geological exploration on Earth. We searched for life in space and ultimately improved life on our own planet. But technological legacy is just the tip of the iceberg. Much more profoundly, the search for extraterrestrial life has reshaped our self-awareness, bestowing upon us new concepts and a fresh perspective for looking at ourselves. Consider the word biosphere. Today, it seems familiar and understandable, but it entered widespread use precisely thanks to space exploration. Only by seeing our planet from afar, a small, fragile blue marble adrift in the black void, did we truly grasp that we live within a single, self-contained, and incredibly vulnerable system. The concept of Spaceship Earth traveling through the cosmos with its entire crew was born precisely from this experience. We stopped perceiving nature as an infinite resource and began to see it as the thinnest film of life, so easily damaged. The environmental movement, to a great extent, was born from this cosmic perspective on our shared home. Another vivid illustration of how a scientific concept permeates popular culture is the famous Prime Directive from the Star Trek universe. The principle of non-interference in the development of less advanced civilizations, which became a moral compass for Captain Kirk and his successors, wasn't invented by screenwriters from scratch. It's a direct artistic interpretation of a very real and strict scientific principle of planetary protection, which we discussed earlier. Scientists worried about contaminating Mars with Earth microbes, and fictional starship captains afraid of disrupting the cultural development of an alien world are two sides of the same coin. This is a profound ethical idea that originated in NASA's sterile cleanrooms and then became part of global pop culture, shaping moral guidelines for millions of people who may have never even heard of actual planetary protection protocols. However, this legacy also has its dark, paradoxical side. As often happens, a great and complex idea was eventually distorted and transformed into its opposite. The rational scientific search for extraterrestrial life, based on rigorous evidence and intellectual honesty, gave birth to its ugly and irrational reflection: ufology and conspiracy theories. Scientific skepticism was replaced by blind faith. The principle that extraordinary claims require extraordinary evidence morphed into the absence of evidence is proof of a government conspiracy. Thus, the sober and cautious study of anomalous radio signals mutated into tales of abductions and secret alien bases. Serious discussions about possible forms of alternative biochemistry were supplanted by cartoonish images of little green men. Instead of the scientific method, based on doubt and verification, a quasi-religious doctrine emerged, demanding belief and rejecting any criticism as the machinations of enemies. The search for extraterrestrial intelligence, conceived as a triumph of human intellect, inadvertently created a breeding ground for the most primitive and anti-scientific prejudices. This paradox is a great lesson about human nature. The quest for knowledge and the drive for belief are two powerful forces living within us, and sometimes, as we see, one can accidentally feed the other. The legacy of the search for extraterrestrial life is twofold. On one hand, it has given us new technologies, new ethics, and a new perspective on our world. On the other, it has created a new, modern mythology that parasitizes on a grand idea, yet at the same time proves its incredible power and allure for the human mind. Now, in the 21st century, we live in a world drowning in information. Every day, an informational tsunami crashes over us. News, social media, advertisements, opinions from experts and pseudo-experts. billions of voices shout simultaneously, and in this deafening chorus, it becomes almost impossible to discern the truth. We are surrounded by noise, and this challenge, which our generation faces, painfully resembles the task that astronomers have been grappling with for half a century while searching for extraterrestrial intelligence. They, too, are trying to find a single meaningful signal in the boundless ocean of cosmic noise. Their challenge and ours are structurally identical. Cosmic noise isn't merely a faint hiss. It's quasars, pulsars, background radiation, radio galaxies, thousands of natural sources generating powerful signals capable of masking or mimicking artificial ones. Our informational noise isn't mere chatter either. It's targeted propaganda, fake news, viral marketing, algorithms that create reality bubbles and feed us what we want to see. In both cases, the main difficulty lies in distinguishing a genuine signal from an incredibly complex and convincing imitation. And this brings us to the crucial, non-trivial lesson imparted by the Great Search. Scientists from the SETI project realized long ago, to find a signal merely possessing a sensitive receiver isn't enough. The key is to have a perfect filter. Their primary work isn't listening, it's excising. They create highly complex algorithms to filter out all known natural sources, all terrestrial radio interference, all satellite noise. They seek an anomaly, what remains after everything explainable has been discarded. They teach machines to ignore 99 and 9/10% of the information to focus on the 1/1,000,000th that might prove significant. This lesson has direct relevance to our daily lives. The most crucial skill for survival and development in the 21st century isn't the ability to rapidly absorb information, but the capacity to critically filter it. We must construct our own intellectual filters, learning to distinguish facts from opinions, verified sources from anonymous disinformation, scientific data from ideological manipulation. We need to cultivate what could be called informational immunity, the ability to recognize and reject the mental viruses that seek to infect our consciousness. Perhaps the deepest lesson we can glean from this entire narrative is even more subtle. In attempting to find and identify extraterrestrial intelligence, we are inevitably compelled to define what precisely is intelligence itself. What is our own human intelligence? What do we consider the primary hallmark of intelligence? Is it the capacity for mathematics, for art, for compassion? That very golden record on Voyager wasn't merely a message for extraterrestrials. It was our first desperate attempt to describe ourselves, to select the most vital and valuable aspects of our entire experience, and to declare, this is what it means to be human. In this light, the great silence of the universe is no longer just a mere absence of a signal. It transforms into a colossal mirror, reflecting our own questions back at us. When we ask, are we alone? What we're really asking is, who are we? Searching for extraterrestrial intelligence is, in essence, searching for a definition of our own. Gazing into the silent void, we are ultimately not seeking them, but ourselves. And perhaps this very quest is the fundamental meaning of our existence. In any detective story, to grasp the motives behind a crime, one must attempt to step into the criminal's shoes. In our cosmic investigation, the universe itself plays the role of this metaphorical antagonist that seemingly conceals the truth from us. And here, we must take a crucial step: deconstruct this very image. The universe is not some comic book villain cunningly hiding other civilizations from us. It possesses no will, no consciousness, and no intentions. It is a gigantic, indifferent system, operating according to its own immutable laws. Its logic is the logic of physics, chemistry, and thermodynamics. And if we truly wish to comprehend the nature of the Great Silence, we must cease attributing human motives to it and endeavor to view the world from its systemic perspective. So, what is the universe's truth? Its primary principle is efficiency and the path of least resistance. It does not strive for complexity's sake. It strives for stability. Stars, galaxies, planets, all are stable, energetically favorable states of matter. Life, from this viewpoint, is also merely a chemical process that has discovered an efficient means of dissipating energy and sustaining its own existence. A carbon base, liquid water, these are not some divine recipe, but simply the most successful and widespread engineering solution that allows this process to function across a broad range of conditions. To the universe, there is no distinction between a colony of bacteria thriving at a hydrothermal vent and a megalopolis housing 1 billion inhabitants. Both are merely localized pockets of increased entropy, methods of energy processing. Now, let's perform this mirroring trick. How wild, incomprehensible, and even ludicrous must we appear, we humans, from the perspective of this impersonal system? Imagine this. On a tiny speck of dust, orbiting an unremarkable star at the edge of one of hundreds of billions of galaxies, a delicate film of carbon-based slime emerges. For 3.5 billion years, this slime quietly and peacefully goes about its business: photosynthesis, chemosynthesis, reproduction. And then, in the last, vanishingly small moment of its existence, a minuscule fraction of this slime goes absolutely wild. It begins constructing intricate metallic structures, splitting the atom, and directing concentrated beams of radio waves into the void, shouting meaningless sequences of prime numbers into the abyss. To the fundamental laws of the universe, this appears as an absolute anomaly, a statistical error, a strange and energetically inefficient glitch in the program. The cultural shock, if such a thing were possible, would boil down to this very question. Why? Why does this particular form of matter expend a colossal amount of energy not on survival and reproduction, but on producing meaningless, narrow-band noise? This behavior is illogical from the perspective of the system's basic principles. The universe speaks the language of gravitational waves, neutrino fluxes, and the broadband electromagnetic radiation of stars. Our attempt to converse with it via radio is akin to an ant trying to establish contact with a human by rhythmically waving one of its 6 legs. We aren't just speaking different languages, we exist in different ontological categories. And this is where we encounter the tragedy of predictability. The universe's greatest strength lies in its immutable order and the stability of its laws. For billions of years, it has operated like clockwork, creating predictable and stable structures: stars, planets, oceans, microbial mats. This system is perfectly tuned for generating simple, long-lived forms. Its power stems from its inertia, its conservatism. And it is precisely this strength, this order, this penchant for simple and stable solutions that has become its weakness from the perspective of intelligence generation. A system that successfully produced bricks for billions of years found itself unprepared for one of those bricks suddenly imagining itself an architect. The emergence of technological intelligence is not the next logical step in the universe's evolution. It is, more likely, an exceedingly rare and collateral phenomenon, a glitch in the matrix that disrupts the familiar, orderly course of events. The universe is strong in its tradition, and our civilization is a challenge to that tradition. We are the vanguard that the system neither planned for nor was ready to receive. Therefore, when we gaze upon the silent cosmos, we should not see an adversary. We should see another civilization, the civilization of physical laws. And this civilization is not hiding from us. It simply operates by its own rules, rules that have no place for dialogue. The Great Silence is not a conspiracy. It is the natural state of a system that excels at creating life, but almost never cultivates it to the stage where it begins to ask questions. We are alone, not because someone has isolated us, but because we are the exception that proves the fundamental rule of cosmic indifference. The Great Search, for all its scientific rigor, has always been infused with a spirit of idealism and hope. But beneath the facade of this noble endeavor lies a darker side, fraught with moral compromises and human dramas. One of the most controversial decisions in the history of this quest was the famous Arecibo message. In 1974, using the colossal radio telescope in Puerto Rico, a group of scientists, including Carl Sagan and Frank Drake, broadcast a powerful and complex radio message into space aimed at the globular star cluster M13. It was an act of cosmic existentialism, a shout into the void containing information about our DNA, our solar system, and our appearance. But what if it wasn't a greeting, but a fatal mistake? What if the dark forest hypothesis is true, and our signal merely revealed our location to predators? This decision, born of the best intentions, could prove to be the most lethally dangerous message in a bottle ever cast into the ocean. We still don't know whether it was an act of brilliant humanism or reckless naivete, and the weight of that uncertainty burdens the entire project. To understand the cost of this brilliance, one must look at its creators. Frank Drake, the founding father of the SETI project, was a young, enthusiastic astronomer in 1960 who, for the first time in history, aimed a radio telescope at two nearby stars in the hope of catching a signal. Imagine his inner state. He was a Columbus setting sail for the shores of a new world, capable of making the greatest discovery in history at any moment. His entire body of work was imbued with an almost youthful optimism. He created his famous equation not to prove that we are alone, but quite the opposite, to demonstrate how great the chances of success truly were. He was an idealist, believing in the triumph of reason and curiosity. But years passed, then decades. Optimism gave way to patience, patience to stoicism. Imagine the psychological burden on this man. His entire life was dedicated to an idea that never bore fruit. He became a symbol of a great hope that, with each passing year of silence, transformed into a great disappointment. This wasn't a defeat in a single battle. It was a long, exhausting siege by silence. The solitude at the peak of this intellectual pyramid was absolute. He watched his colleagues make discoveries, receive Nobel Prizes for detecting pulsars and gravitational waves, while his own project, the most ambitious of all, continued to yield the same result: zero. The constant pressure and the need to defend his idea from skeptics inevitably changed him. The idealist transformed into a wise, yet profoundly lonely philosopher who, until the end of his days, no longer looked at the stars with the question, "When will you answer?" but with a quiet and sorrowful query, "Do you even exist?" But brilliance demands sacrifices not only from its leaders. The fates of dozens of other, less-known scientists were laid upon the altar of this great quest. In the shadow of giants like Sagan and Drake, there were always engineers and astronomers who did all the grunt work. And the most vivid symbol of their sacrifice was the tragic fate of the Arecibo telescope itself. For nearly 60 years, this colossal 300-meter dish, nestled within a karst sinkhole, was humanity's primary ear, its hope of hearing the universe. It was not merely an instrument, but a sacred place, a mecca for all who believed in contact. The people who worked there were not merely observatory staff. They were a brotherhood, almost a religious order, united by one grand idea. They lived nearby, their children attended the same school, and for decades they ascended to the precarious platform, hanging 150 meters above the dish to service its receivers. They sacrificed careers in more mainstream fields of astronomy for this dream. Their work didn't yield splashy publications, but they believed their contribution was the most vital. They were the unnamed sentinels on watch over the great silence. Their sacrifice became visible and horrifying in late 2020. Due to years of underfunding and an aging structure, first one of the supporting cables snapped, and then, on the night of December 1st, the entire 900-ton instrument platform plummeted, piercing and destroying the legendary dish. This was not just a collapse, it was a symbolic act, the end of an era. The magnificent instrument, built to search for intelligence, was obliterated due to human neglect and a lack of funds. Dozens of scientists and engineers lost their life's work overnight. The story of Arecibo is the most precise and brutal metaphor for the price of brilliance. A grand idea spawned a grand instrument, which in turn demanded decades of self-sacrifice from those who served it. And in the end, it was forgotten and left to die, burying beneath its rubble not only tons of metal, but also the hopes of an entire generation of researchers. This is the true cost of ambitions directed at the stars. Sometimes they conclude not with a triumphant discovery, but merely with the deafening clang of falling iron. For centuries, two great intellectual cultures existed in almost complete isolation from each other. On one side was astronomy, the science of the majestic, cold, and dead. It spoke the language of mathematics, gravity, and light, describing the ideal, predictable movements of celestial bodies. Its world was one of sterile order. On the other side was biology, the science of the warm, chaotic, and living. It spoke the language of DNA, proteins, and evolution, studying a unique, almost miraculous phenomenon that occurred on one single planet. When the search for extraterrestrial life became a serious scientific endeavor, these two universes inevitably collided. And at first, it was not a harmonious synthesis, but a harsh, irreconcilable conflict. Biologists viewed astronomers as naive dreamers, squandering trillions of planets without grasping how fragile and improbable life itself truly is. Astronomers, in turn, saw biologists as narrow specialists who, due to studying a single example, were incapable of appreciating cosmic scales and statistical inevitability. This conflict was, at its core, a clash of languages and worldviews. When an astronomer spoke of an Earth-like planet, they envisioned a rocky sphere of a specific size within the habitable zone. For a biologist, however, those words meant next to nothing. They needed data on the presence of plate tectonics, the strength of magnetic fields, the chemical composition of oceans, or the existence of a stabilizing moon. When a biologist spoke of metabolism, they implied an intricate network of thousands of enzymatic reactions. For an astronomer, however, this was an abstract concept they hoped to reduce to the mere presence of methane in an atmosphere. It was a dialogue between the blind and the deaf, a theoretical physicist conversing with a field zoologist. They used the same words, yet infused them with entirely different meanings. But from this inevitable collision, from this intellectual melting pot, something entirely new began to emerge over time. Astonishing and peculiar scientific hybrids appeared, belonging to neither of the parent cultures. Thus was astrobiology born, a science that endeavors to study life we have yet to witness on planets we cannot reach. This hybrid behemoth compels geologists to scrutinize not terrestrial rocks, but the light spectra of distant stars to discern if continents exist there. It is a science that forces organic chemists to model reactions not in a test tube, but in the hypothetical methane seas of Titan at a temperature of -180 degrees Celsius. The most striking example of such a hybrid is the concept of a biosignature. This is neither a living organism one can touch, nor an astronomical object one can measure. It is an indirect indicator, a chemical ghost of life, frozen in an atmosphere across interstellar distances. The quest for biosignatures is the quintessence of this new, hybrid thinking. Another astonishing hybrid born from this union is the contemporary study of extremophiles. Biologists had previously known about bacteria living in geysers or salt lakes, but this was merely a curious subfield of microbiology. However, when astronomers introduced the idea of subsurface oceans on Europa and Enceladus, the study of extremophiles transformed into one of the key avenues of research. Now, biologists descend into the deepest mines and drill into Antarctic ice, not merely out of curiosity, but with a specific objective. They are searching on Earth for analogues of life forms that could survive in space. This is biology in service of astronautics. It is the search for extraterrestrials within a single droplet of water from a terrestrial volcano. How then has this grand synthesis reshaped the daily life of a scientist at the crossroads of these civilizations? Fundamentally, just 30 years ago, a geologist studied rocks lying beneath their feet. Today, their colleague operates a robotic arm on a Mars rover hundreds of millions of kilometers from Earth, making decisions about drilling into rock they perceive only after a multi-minute signal delay. An oceanographer who once deployed a bathyscaphe into the Mariana Trench now models tidal currents within Europa's subsurface ocean. The old habit of peering through a microscope has given way to a new one, poring over spectrometer data, and the custom of fieldwork has been replaced by the practice of writing code to analyze data from a space telescope. Their world is no longer flat. It has gained a third cosmic dimension. But the lives of ordinary people, those unconnected to science, have also changed. The old, familiar picture of the world was simple and clear. Here was our vibrant, unique home, Earth, and there was dead, hostile space. Today, that boundary is blurred. New, habitable territories have emerged in our consciousness. Mars with its dried-up rivers, Europa with its hidden ocean, Titan with its methane lakes. Space is no longer merely a void. It has become a repository for potential life. The very notion that the building blocks of life, amino acids, arrived on comets alters our perspective on these icy behemoths. They are no longer mere cosmic debris, but our chemical ancestors, our progenitors. We are no longer orphans in the universe. We have begun to realize that we are part of a colossal, unified process, and our home is not a fortress, but merely one of countless islands in a boundless cosmic ocean. Let's be honest, science is not solely a pure quest for truth. It is also a battle for minds, for funding, and for a place in the cultural hierarchy. And in this struggle, as in any political arena, its own technologies of propaganda and counter-propaganda are employed. The grand search for extraterrestrial life has, from its very inception, been a battlefield of fierce information warfare. Its primary protagonist, the very idea of the search, required a powerful public relations campaign to survive. And the principal architect of this myth was, without a doubt, Carl Sagan. He understood that for the broad public and for the members of Congress allocating budgets, dry scientific data would not suffice. A grand, inspiring narrative was needed, and Sagan created it. He purposefully constructed the public image of the search, employing not merely facts, but powerful poetic symbols. The famous pale blue dot photograph is not merely a picture. It is a masterpiece of propaganda, compelling anyone to feel the insignificance of our earthly squabbles in the face of the cosmic abyss. The Voyager Golden Record is not a scientific experiment, but a stroke of public relations genius, a symbolic act transforming a cold piece of metal into a messenger for humanity. Sagan did not lie. He forged a mythology of a noble, humanistic quest that elevates us. Naturally, this campaign immediately garnered its adversaries, who launched a potent counter-propaganda effort. Their primary weapon was not refutation, but ridicule. They crafted and aggressively promoted a caricature of SETI scientists as eccentrics who squandered taxpayer money on the search for little green men. This simple, biting phrase proved to be incredibly effective black propaganda. It reduced a highly complex scientific problem to a children's fairy tale and painted researchers as infantile dreamers. The most prominent representative of this party of skeptics was American Senator William Proxmire, who in 1978 awarded the SETI project his infamous Golden Fleece Award for what he deemed the most senseless squandering of government funds. This was a public chastisement aimed at discrediting the very idea of the search in the eyes of the public and the political establishment. And some of these counter-propaganda myths proved remarkably tenacious, persisting even to this day. Chief among them is the enduring misconception that the absence of a signal constitutes proof of life's absence. From a logical standpoint, this is a blatant logical fallacy known as an argument from ignorance. But as a propaganda thesis, it works impeccably because it appeals to common sense. If they were out there, we would have heard them by now. This myth weaponizes the very results of the search against itself, twisting the decades-long patience of scientists into proof of their failure. Another tenacious myth is the image of the astrobiologist themselves. Thanks to counter-propaganda, in the popular imagination, they are still often depicted not as rigorous data analysts, but as a somewhat unworldly enthusiast, teetering on the edge of science and faith. And here we arrive at the classic adage, history is written by the victors. Consider one particular event, the famous wow signal. In popular culture, in books and documentaries, it is presented as a supreme enigma and an almost mystical occurrence. The official, victorious narrative of this story goes like this. We captured a powerful, narrowband signal from the depths of space that bore all the hallmarks of artificial origin. It never recurred, leaving us with the greatest mystery. This version captivates, intrigues, and fosters hope. But if we turn to the archaeological data, that is, to the dry scientific facts and alternative interpretations, the picture becomes far more prosaic. We do not know the exact source of the signal. Several hypotheses exist about its terrestrial origin, for example, a reflection off space debris. And most importantly, its non-recurrence is the strongest argument against it being a deliberate beacon from an intelligent civilization. But this dull, losing version of the story interests no one. The beautiful myth triumphed. The same thing happened with the results of the biological experiments aboard the Viking missions. The official story, the one everyone knows, states, "The Vikings searched for life on Mars and found nothing." This is a simple, understandable, and long-dominant version. However, the losing side's data tells a completely different story. One of the 4 experiments, the so-called labeled release, yielded a clear positive result, entirely consistent with the expectations of microbial metabolism. Its creator, scientist Gilbert Levin, insisted until his death in 2021 that his instrument had detected life. But the scientific community ultimately adopted a different, more cautious interpretation, attributing the result to unusual Martian soil chemistry. Thus, the victorious version of life's absence was born, and decades of debate and the ambiguity of the actual data were virtually erased from the popular narrative. This information war has not ended. It continues even today. On one hand, scientific organizations like NASA phrase their press releases with extreme caution, speaking of organic molecules, which are not equivalent to life, or potentially habitable conditions. They conduct their carefully calibrated information policy. On the other hand, tabloids and conspiracy theorists snatch up these phrases and transform them into sensational headlines like "NASA found life and is hiding it." We live at the epicenter of this battle of narratives. And as always, the truth is not found in the grand pronouncements of the victors or their adversaries, but in the quiet, dry, and complex scientific papers that few people bother to read. The original intent behind the grand quest was simple, pure, and almost innocent. It sprang from fundamental human curiosity, from the eternal question of a child gazing at the night sky. Is anyone out there? This was a search for knowledge, for understanding our place in the universe. Scientists sought a signal, a biomarker, any hint of an other to alleviate the crushing feeling of cosmic solitude. The goal was philosophical, contact and comprehension. But any pure idea colliding with harsh reality risks distortion. And at some point, unnoticed by most, a fundamental shift occurred. The end no longer justified the means, because the end itself had changed. A second point of no return had arrived, the moment when the search for extraterrestrial life was betrayed from within. This fateful decision wasn't made in a single meeting. It matured slowly, under the pressure of very earthly problems: climate change, resource depletion, population growth. Humanity, confronted with a threat to its own home, began to gaze at other worlds, not with curiosity, but with covetousness. The search for exoplanets, which began as a way to find intelligent brethren, transformed into a hunt for Planet B, a casting call for our cosmic contingency plan. The search for their home became the search for our new home. The tools, telescopes, spectrometers, computer models remained the same, but their ultimate purpose was cynically rewritten. The grand philosophical quest mutated into history's most ambitious cosmic real estate project. This tectonic shift sparked a profound schism within the scientific community, best described as a clash between two former allies. On one side stood the archetypal philosopher-astronomer, a true intellectual successor to Carl Sagan, for whom the cosmos was a sacred temple of knowledge. He believed our duty was to listen, to observe, and under no circumstances to interfere. He sought the strange, the anomalous, the utterly alien. His primary tool, the analysis of biosignatures, those subtle chemical anomalies that might betray the presence of an exotic biosphere. On the other side rose the astro-engineer, a new-wave pragmatist aligned with government agencies or private corporations. Philosophical musings held no sway for him. His mission was to pinpoint planets ripe for colonization. He sought not the alien, but the familiar: water, oxygen, stable geology. He wasn't searching for biosignatures, but for what could be termed geosignatures, the telltale signs of habitability and terraforming potential. Their dialogue was a clash of two worlds. "You've betrayed the dream," the philosopher would thunder. "You've perverted a noble quest into a cynical resource hunt. We sought kindred spirits, but you seek slaves or territory for conquest. We are becoming the very cosmic barbarians we always feared encountering." To which the engineer would retort with a cold, almost mocking smile: "Your dreams are a luxury we can no longer afford when our own house is burning down. What good is finding sentient brethren if in 200 years there'll be no one left on Earth to read their message? I'm not betraying the dream. I'm saving the dreamers." This was an irreconcilable conflict between the pursuit of knowledge and the raw will to survive. A symbolic act that sealed the pragmatist's ultimate victory was the radical shift in priorities for the James Webb Space Telescope. Initially, it had been heralded to the public as the paramount instrument for detecting signs of life. But over time, its observation targets less and less frequently included strange planets with potentially intriguing yet enigmatic atmospheres. Instead, boring worlds, those maximally similar to Earth, began to dominate the celestial roster. Top priority shifted from planets that might harbor exotic life to those where humanity could survive. The detection of phosphine in Venus's atmosphere sparked a fervent but fleeting debate. However, the discovery of water vapor on a super-Earth within a calm star's habitable zone became headline news, because it signaled a prime candidate for colonization. The search for the miraculous was officially superseded by the search for the mirror. This betrayal of an ideal had far-reaching ramifications. It fundamentally reoriented the very vector of scientific progress. Efforts were no longer poured into designing communication systems for hypothetical interstellar dialogue, but into engineering concepts for interstellar vessels capable of delivering frozen embryos to distant worlds. Theoretical biology shifted its focus away from modeling alternative biochemistries and increasingly toward the adaptation of terrestrial organisms to alien planetary conditions. The quest for extraterrestrial intelligence was demoted to a mere applied task within the grander program for the survival of Homo sapiens. And herein lay the profoundest irony. We began gazing into space to escape our problems, to flee our aggressive expansionist nature. We hoped that encountering the other would make us better, wiser, more humane. But ultimately, we couldn't endure the prolonged silence. We feared the solitude and our own vulnerability, and chose to fill that void with ourselves. Instead of waiting for an invitation, we began compiling a list of homes we could break into when our own was reduced to ashes. The grand quest, meant to elevate us beyond our nature, became its supreme and most expansive manifestation. This ideological upheaval, this quiet yet tectonic shift from the search for contact to the search for living space, didn't merely remain confined to the walls of scientific institutions. It percolated into society, reshaping its structure, its economy, and most crucially, its very soul. In this brave new world, the victors weren't philosophers, but managers. The new elite consisted not of visionary scientists, but of aerospace corporation chief executive officers, genetic engineers, terraforming specialists, and military strategists overseeing the security of interstellar missions. They spoke not in terms of probabilities and hypotheses, but in the lexicon of profitability, logistics, and risk. Their public addresses weren't poetic musings on humanity's place in the cosmos, but crisp, meticulously calibrated business presentations detailing the cost of delivering a single kilogram of payload to Proxima Centauri's orbit. The losing side comprised the proponents of the old, humanistic ideal. Scientists who continued to advocate for listening and non-interference were branded as reactionaries, idealists, actively hindering progress and jeopardizing the survival of humankind. Their institutions were stripped of funding, and their voices were drowned out by the chorus of pragmatists offering not hope, but an evacuation plan. This new objective spawned a new economy, built quite literally on the bones of the old science. Vast resources once allocated to fundamental research, to constructing particle colliders or radio telescopes, were rerouted into applied fields. Instead of pouring billions into the elusive search for gravitational waves, governments and corporations began funding materials science for creating solar sails, cryobiology for freezing colonists, and robotics for constructing extraterrestrial infrastructure. Money flowed like a river, but it was a river that bypassed old universities and emptied into the colossal reservoirs of new scientific industrial clusters, where science was inextricably linked with manufacturing and military contracts. This also redrew the entire geopolitical map of the world. Old centers of power, once anchored by control over oil or finance, began to yield to new ones. The primary resource shifted from energy to information and technology. A nation or corporation possessing exclusive data on the atmospheric composition of a promising exoplanet gained leverage comparable to owning nuclear weapons. A new Cold War began, a war for data, for patents on terraforming technologies, for the prime starting positions in the coming race for colonization. The trade routes of the future were no longer charted across oceans, but across star maps. Access to space ceased to be a matter of prestige and became a question of national survival. But the most profound changes manifested in society's collective psychology. It plunged into a state best described as a collective manic-depressive syndrome. On one hand, a deep, subconscious trauma emerged. The chilling realization that our home, Earth, was not eternal. That it was not a cradle, but merely a temporary haven, one that we ourselves had, moreover, rendered uninhabitable. This spawned a constant background hum of anxiety, a feeling of living on a sinking ship. The notion of our common home was replaced by the image of our common burning house. On the other hand, to counteract this existential dread, society spiraled into a manic euphoria. The new grand project, space colonization, became the perfect narcotic, allowing distraction from pressing problems. It offered a new purpose, a new frontier, a new American dream, only now on a galactic scale. Why grapple with the agonizing problems of ocean pollution when one could dream of pristine, new oceans on Kepler 186f? This euphoria was a defensive mechanism, a way to avoid succumbing to fear and despair. Ultimately, this completely reshaped humanity's worldview. The relationship with Earth became purely utilitarian. It transformed from mother into a mere resource. Why preserve endangered species if, in 300 years, we'll all be gone anyway? Why care about the legacy of our ancestors if our future lies on another planet? A transient mentality took hold. Our planet came to be perceived as a disposable cup, to be drained to the last drop to fuel our leap to the stars. And this cynical consumerist philosophy, born of fear, became the paramount psychological legacy of a society that had weathered the shock of betraying the grand dream of encountering the other, replacing it with the much simpler, more comprehensible dream of saving itself. This tectonic shift from passive listening to active expansion wasn't merely a pragmatic decision dictated by fear. To justify such a radical change in course and to mobilize all of civilization's resources toward it, a powerful philosophical foundation was required, and it was created. The new idea that captured minds and began to govern policy could be called cosmic expansionism, or the doctrine of panspermia of consciousness. Its essence was simple, yet incredibly seductive. It posited that the rarest and most valuable phenomenon in the universe was not life itself, but self-awareness. Microbes might teem everywhere, but matter's ability to be conscious of itself, to create art, science, and philosophy, that was almost a miracle. And if we, humans, were the only known carriers of this miracle, then our chief moral duty was not merely to preserve this tiny spark on one fragile planet, but to ignite it into a wildfire that would engulf the entire galaxy. Our mission was not to listen, but to speak, not to seek, but to sow. The intellectual driving force, the grey eminence of this new era, was neither a politician nor a businessman, but a philosopher and futurologist named Adrian Wayland. He was a man with an intellect as cold as space itself, and a gift for clothing the most brutal ideas in impeccably logical and persuasive forms. In his seminal work, which became the Bible of the New Age, The Last Filter, Consciousness, and the Imperative of Expansion, he inverted the entire logic of the search. He argued that the great silence of the universe was not a mystery, but an answer. It was the clearest and most terrifying answer we had ever received. Wayland's logic was merciless. He declared, "For decades you've searched for great filters in the past, trying to understand why others didn't reach our level. You're looking in the wrong place. The great silence proves that the primary filter isn't behind us, but ahead. It's the very choice facing us right now. All those countless civilizations that might have existed before us made the same choice as you humanists. They decided to stay home, to listen, to hope, and not to interfere. And where are they now? They were swallowed by one of 1,000 cataclysms, an asteroid impact, a supernova explosion, their own ecological disaster. Their silence is a scream from beyond the grave, a warning to us. The only way to pass the last filter is not to stay on one planet, but to become an interstellar species. Expansion is not aggression. It is the only scientifically known way to combat death." Opposing this powerful and grim doctrine was the old philosophy, now dubbed cosmic humanism, or the ethics of listening. Its adherents, the intellectual heirs of Sagan, asserted that true value lay not in spreading one's own kind, but in the possibility of encountering the alien. Their central argument rested on a moral imperative. We have no right to turn other worlds, even barren ones, into our colonies, because we cannot know if, in doing so, we might destroy the conditions for the future emergence of unique life, unlike our own. By populating the galaxy with ourselves, we risked forever sterilizing it, filling every ecological niche with a single terrestrial life form. They accused Wayland and his followers of cosmic solipsism, an inability to imagine the value of anything beyond themselves. The contention between these two ideas defined the intellectual life of the era. You propose we commit genocide against potential life for our own salvation, the humanists cried. And you propose we commit guaranteed suicide out of sentimental attachment to a hypothetical alien amoeba, the expansionists coldly countered. It was a fundamental conflict between an ethics of duty toward the other and an ethics of duty toward one's own, between the hope of discovery and the sheer will to survive. Ultimately, Whelan's philosophy triumphed, not merely because it offered a clear roadmap in the face of absolute uncertainty, but because it presented humanity with a new, far more flattering role. The philosophy of listening cast us as small, humble pupils in a vast cosmic classroom. But the philosophy of expansion transformed us into missionaries, carrying the light of reason into a dark, unreasoning universe. It transmuted our fear and loneliness into proof of our exceptionalism. We weren't just saving our own skins, we were fulfilling a grand cosmic mission. This pivot from humility to hubris, from passive expectation to decisive action, became the philosophical bedrock upon which the edifice of a new interstellar humanity was erected. Any grand system built around a singular genius or a single all-consuming idea is doomed. It sustains itself on the intellectual gravity of its creator. But the moment the creator departs, or the idea reaches its zenith, that gravity dissipates. And then the system, stripped of its core, begins to devour itself. Such was the fate of the great cosmic expansion project. Immediately following the death of its ideologue, Adrian Weyland, the system encountered no external enemies. It didn't require any external threats. It began to crumble under its own weight, torn asunder by internal contradictions that had previously been held in check only by the force of a single personality. The grand mission that had united humanity transformed into a gargantuan corpse to which vultures flocked. These vultures were his own heirs, the corporate titans, military leaders, and political factions who during Whelan's lifetime had been forced to bow to his authority. Now they were unleashed. A ferocious and ugly struggle for the inheritance ensued. They didn't abandon the idea of expansion, no. They did something far worse. They tore it to shreds, eviscerated its entire philosophy, and warped it into a mere instrument for achieving their own petty and self-serving ambitions. Each faction interpreted the grand imperative of expansion to their own advantage. For the corporate bloc, it became the imperative of profitability. The primary objective was declared to be resource extraction and the colonization solely of worlds promising maximum returns. For the military, it transmuted into the imperative of security. The mission shifted to the militarization of space and the establishment of control over strategic points to outmaneuver rivals. For the religious and ideological factions, it morphed into the imperative of purity. They saw space as an opportunity to construct new, righteous societies unburdened by the sins of old Earth. The grand dream of a unified humanity bearing the light of reason was torn into three distinct parts: a business plan, a military doctrine, and a utopian sect. They plundered Whelan's legacy, reducing it to mere sound bites for their promotional brochures and political campaigns. Yet, amidst this frenzy of self-serving dismemberment, one last bastion of defiance remained, a singular ember of resistance that held true to the genuine, original vision. It was not a person, but a project, the autonomous Legacy Foundation, established by Whelan himself as his crowning achievement and ultimate endeavor. The Foundation oversaw a single mission that embodied the pure philosophy of expansionism. This was the generation ship Archivist, whose purpose was not colonization, not resource extraction, and not the establishment of power. Its mission was something else entirely: to reach a distant, predetermined star system, and without landing, to seed its lifeless planets with archives of human knowledge and a bank of terrestrial DNA. This was an act of pure, selfless panspermia, a gift to the universe with no expectation of reciprocity or reward. The crew of the archivist consisted not of soldiers or entrepreneurs, but of scientists, philosophers, and engineers who were the last custodians of the true faith. To the new masters of the solar system, this ship was a stark reproach. It was a living indictment, a painful reminder of a dream betrayed. It generated no profit. It conquered no territories. From their perspective, it aimlessly squandered colossal resources. And so, the corporations and the military, perennially at odds with one another, forged a temporary alliance with a singular objective: to intercept and reassert control over this final vestige of the past. What transpired next went down in history as the chase for the archivist. It was a tragic and unequal battle. A fleet of swift, nimble warships pursued the slow, ponderous arc of knowledge across the entire solar system. The climax of this drama unfolded at the rings of Saturn. The crew of the archivist, understanding their mission was doomed, made a final, defiant choice. Instead of surrendering, they piloted their vessel directly into the dense ice rings, choosing death over capitulation. The gargantuan ship, carrying the entirety of human knowledge and hope, was ripped apart by gravity and collisions with icy behemoths. Its remnants, mingling with ice and dust, formed a new artificial ring around Saturn, a glistening, sun-kissed memorial to a grand idea. This radiant, beautiful demise marked the end of an entire epoch. The dream of a unified, philosophically profound expansion perished with the archivist. Humanity continued its journey to the stars, but it was no longer a soaring flight, but a fevered, uncoordinated scramble. The age of grand mission concluded. The era of interstellar feudalism and cosmic piracy, waged under the banners of ideologies and corporate brands, had begun. Following the demise of the archivist and the ultimate triumph of interstellar feudalism, the original concept of the Great Search was not merely forgotten, it was systematically erased from history. In the new, pragmatic and aggressive culture focused solely on expansion, the old philosophy of listening came to be seen as a heresy, a symbol of weakness and indecision that had almost led humanity to ruin. The names of Carl Sagan and Frank Drake were struck from official textbooks or mentioned only in footnotes as examples of dangerous idealism. Their works were purged from public libraries and relegated to deep, encrypted archives, marked ideologically harmful materials. The very acronym SETI became a pejorative. New generations, born in space aboard corporate stations or in early colonies, grew up with the firm conviction that space was empty, silent, and simply a trove of resources to be seized before competitors could. For several centuries of oblivion, humanity spoke to the cosmos in only one language, the language of laser drills, plasma engines, and ballistic missiles. But nothing truly vanishes without a trace. Great ideas, like dormant seeds, can lie in frozen soil for centuries, awaiting their opportune moment. The moment of rediscovery arrived not in the heart of one of the mighty corporate empires, but on the farthest periphery, in a dusty, forgotten archive on a tiny asteroid colony in the Kuiper Belt. It was not made by a celebrated scientist, but by a young, unknown data archaeologist named Elara. Her work was monotonous and tedious. She sorted and catalogued trillions of terabytes of digital detritus left over from the first waves of space exploration. One day, while performing a routine procedure, she stumbled upon an anomalously secured data block, marked with a classification she had never seen before. Driven by pure curiosity, she spent several weeks cracking the ancient encryption protocols. What she found inside turned her world upside down. These were the complete, uncensored archives of the SETI project. She saw the original recording of the WOW signal, read the full texts of Sagan's works, and watched his presentation recounting the pale blue dot. She, who had grown up in a world where humanity was the pinnacle of creation and the master of the cosmos, encountered for the first time the idea of cosmic humility, the ethic of non-interference, an almost religious reverence for the possibility of the other. For her, It was like someone who had spent their entire life reading only financial reports, suddenly discovering poetry. She realized that the official history she had been taught was a monstrous lie. Those labeled traitors were, in fact, the last prophets of a bygone, more humane era. This discovery became a second birth for her, and she understood she could not keep it a secret. Risking everything, Elara anonymously uploaded the entire archive to the pirate information networks that connected independent colonies and spacefaring wanderers, everyone who didn't fit into the corporate system. The effect was like an explosion. For thousands of people, weary of cynicism and the perpetual scramble for resources, this forgotten philosophy was a breath of fresh air. It gave them new hope and a new language to articulate their discontent. The movement, dubbed the Return to Listening, began to spread like wildfire across the fringes of human civilization. But here, the central paradox of the long echo became painfully clear. The new era read the old idea entirely in its own way, imbuing it with a meaning that was never originally there. For the scientists of the 20th and 21st centuries, SETI was a rigorous scientific method founded on falsifiability and skepticism. For their distant descendants, living in a harsh and disillusioned world, it became a new religion. They were not scientists, they were believers. They didn't analyze data, they awaited a miracle. In their distorted interpretation, the Great Silence was not a sign of life's absence, but a test sent to humanity by powerful and wise elder races. These elders supposedly observed us, and they would only respond when humanity renounced aggression and returned to a path of peace and contemplation. Listening transformed from a scientific protocol into a form of prayer. A calm intellectual pursuit mutated into a passionate messianic cult, awaiting the advent of cosmic saviors who would solve all problems. Thus, a grand scientific idea, after centuries of oblivion, was reborn as its antithesis, an irrational faith. And this new cult began to gain power, threatening the stability of the already pragmatic new world. And so, having traversed centuries of quests, hopes, disillusionments and wars, we witness the great circle complete itself. History, after a colossal turn, has returned to its starting point, but on a new, far more terrifying level. It all began with a simple, almost childlike question, born from contemplating the night sky. Why is the universe silent? It was a scientific enigma, an intellectual challenge that united the planet's finest minds. Today, centuries later, the Great Silence persists. But it has ceased to be an object of research. It has become a banner under which new armies gather. It has transformed into the primary schism, an existential chasm that has divided humanity into two irreconcilable camps. On one side stands the colossal, pragmatic and ruthless machine of the interstellar empire, for whom the Great Silence is the definitive proof of Adrian Wayland's righteousness. For them, the cosmos's silence is a carte blanche for infinite expansion, a license to conquer and terraform, confirmation that the universe's only law is the right of the strong. On the other side stands the listener's cult, having amassed incredible power and passion, for whom the very same silence is a sacred trial of faith. For them, silence is not emptiness, but the presence of invisible, wise observers who await humanity to prove its right to contact by renouncing violence. Two poles, two faiths, born from the same phenomenon, from the deafening absence of a signal. And therein lies the core, insoluble paradox of our long history. The search for an external other, which was supposed to unite humanity in the face of a grand mystery, inevitably spawned an internal enemy that fractured it. The more desperately we sought intelligence in the universe, the deeper we plunged into our own madness. Every attempt to find proof that we were not alone only intensified our internal discord. The yearning for cosmic brotherhood led us to civil war. We so feared our loneliness that in trying to escape it, we ultimately remained alone, but now within ourselves, divided by a wall of mutual hatred, built on differing interpretations of silence. Perhaps the great silence is more than just an absence of sound. Perhaps it is a perfect mirror. Possessing no inherent features of its own, it thus reflects whoever gazes into it with merciless precision. When optimists like Sagan gazed into it, they saw the promise of wonder and an infinite diversity of life forms. When pragmatists like Wayland looked into it, they beheld only their own reflection, lonely, terrified, and willing to do anything for survival. Now, as two warring factions gaze into it, it reflects both of them, doubling and amplifying their mutual hatred. And as we observe this burgeoning conflict, we understand that the most terrifying war in human history may not begin over resources, nor over ideology, nor over religion in its traditional sense. It may begin over a dispute about the nature of the void. And the greatest irony lies in the fact that the trigger for this war will not be a long-awaited message from the depths of space, but its persistent, stubborn, and unbearable absence. And so now, standing at the precipice of this new era, before two civilizations poised to tear each other apart, the final and most crucial question emerges. Is the great silence of the universe merely a passive blank canvas upon which we are doomed to eternally paint our own fears, hopes, and tragedies? Or is it an active, irresistible force, a kind of dark gravity that inevitably distorts the path of any civilization, forcing it, in the end, to veer from the road of seeking intelligence onto the road of seeking an enemy?